Welcome to EDU World Space.
Okay, in this question there is an frictionless inclination is there like this. Okay, and the height of this inclination is given 3.2 meter. Okay, so it is 3.2 meter and it is 10 meter long. So this the total inclination is 10 meter long. Understand? So a small block of mass 200 gram is kept on the top of the frictionless, okay, is incline. So here the mass is given 200 gram, that is 0.2 kg. Okay, and now there are four parts of the question. Part A, okay, how much work is required to lift the block from the ground and put at the top. So from the ground to put at this top, okay, at the height h 3.2, the total work will be mgh. Okay, so m, that is 0.2, g, that is we just take 10 here, and h, that is 3.2. so when we solve, it will be 6.4 joule. Understand? This will be the answer of part A of this question. Part B, okay, how much work was required to slide the block up to incline. Okay, when we slide this block up to incline, okay, so the work will be force multiplied by the distance. So here distance will be 10 meter and force, okay, so force against, okay, force, it will be mg here. Okay, okay, first of all the block is here and we are doing it incline above. Okay, so force required, so the force that is towards the ground will be mg, and here it will be mg sin theta. Okay, so the work done, it will be four component of force towards the displacement, so that is mg sin theta multiplied by the displacement, that is 10 meter. Okay, so when we solve, mg, m is 0.2, g is 10, sin theta, there is perpendicular divided by hypotenuse, that is 3.2 divided by 10 and multiplied by again 10 from above. So when we solve, it will be 6.4 joule. Okay, so you can understand, if we put this block directly on the top, the work will be same when we slide up from this inclination. Understand? There will be no change in the block. And now we have to find out the velocity in the part C when we drop it from the top. Okay, or in the part D when we drop from the inclination. Okay, so no problem. In the part C, okay, so velocity when we drop, okay, from the when we drop vertically, so the whole energy mgh at the top of the point, that will convert into the kinetic energy, that is half mv square. Okay, so mgh, that is 6.4 joule, we have already calculated, and half mv square. From v square, it will be 6.4 multiplied by 2 divided by m, that is 6.4 multiplied by 2, and m is 0.2. Okay, and when we solve, v square, it will be 6.4 multiplied by 2 divided by 0.2, and it will be 64. So we will do the square root, so we will be 8 meter per second. So when we, that is, drop vertically, okay, so when we drop vertically the block, the final speed of the block will be 8 meter per second. This is the answer of, okay, this is the answer of part C of this question. And now part D, okay, when we slide the box inclinely, okay, on the incline, then what will be the velocity. So when we do the incline, okay, the total work done, that is mg sin theta multiplied by the displacement 10, that is also 6.4 joule. Okay, okay, understand? That is the kinetic energy 1 by 2 mv square. Now when we solve, we will again get the same value. Okay, that is v equals to 8 meter per second. So this implies when we drop the box vertically or we slide by the incline, the final velocity will be same. Okay, and in the part A and B, we conclude that, okay, we conclude that uh, when we put the block direct vertically on the top, and or we can say the slide up on the inclination, the work done will be same. Thank you.